session today. Okay. So to start, the most required thing is your attention. What's the motivation of this presentation is to give you an introduction regarding robotics and mechatronics part. So what you'll be learning is to how to build smart systems like robots and drones. It improves your problem solving skills, and you'll also be learned to use some tools like sensors, motors, Arduinos, softwares like ROS, and some mechanical concepts and all. Most of your STEM part, science, technology, engineering, and mathematics will be used here. 90 all all the physics, mechanics concept you studied in class 11 and 12 will be used for in the mechanical part of robotics. There are upcoming good career opportunities in this field, as you can go through all kinds of magazines today. So first, how do robots works? Actually, there are four broad categories. If you split the robots parts, first are actuators and controllers, sensors, and power supply. The actuator mainly consists of the uh, parts which cause the movement of the robot, like motors, wheels, the subparts inside them. Everything will come under actuators. The controller part will go inside the microprocessor controller inside the robot, which processes the signals and gives them response what to do. And the sensor parts will be like, as it's given in the slides, robots' eyes, ears, and those things. The sensor parts are used of in two ways. First, they use to check whether the operations performed by the robot are perfect. For example, there's a manipulator, a robotic arm, which has to move some 30 degrees. These feedbacks replies will be sent from sensors. Will be scanned by sensors and then sent to brain. There will be a two-way communication between sensors and controller part. They share the information among them, and then they respond accordingly in efficient way. Also, sensors part will be used in the uh, location movement part. If there are some obstacles in the path of a robot, they may be used to avoid them. And the power part, as everyone knows, it consists of the power supply, which batteries use, those stuff, and types of motors. These will be discussed by my friend Ashish. Ashish, you can take over.
Yeah, okay. Am I audible?
Yeah, you are audible.
Okay. So, good evening, everyone. Yeah, myself Aashish. So, I will be discussing about these motors right now. See, the thing is, motors are critical components in everyday life and mechanical systems. Motors convert electrical energy into mechanical motion. So, this helps us to perform a certain tasks like moving, lifting, or rotating. So, in this session, I will cover four types of motors. Those are DC motors, servo, BLDC, and stepper motor. For each, I will explain the working principle, key characteristics, and their applications in robotics. So yeah, starting with DC motors, basically direct current. I think most of you guys are familiar with DC motors. This is also there in class 10th and class 12th. So DC motors are widely used for their simplicity and versatility in robotics applications. DC motor operates on the principle of electromagnetic induction. As you can see in the PPT, there are two permanent magnets which are situated in the sides, and the middle one is an electromagnet which is called a stator. When a direct current flows through the coil, it generates a magnetic field that interacts with the stator's field, producing torque that rotates the motor basically. So there are some brushes which are connected to the commutator. These brushes maintain an electrical contact with the commutator, which helps in rotating the coil. So basically, this helps in the continuous rotation of the motor. The speed of a DC motor is controlled by the input voltage, or else you could call it pulse width modulation. By adjusting this, we can control the speed of the DC motor. Now, this was the working principle of the DC motor. Coming to the characteristics, yeah, it is pretty simple and it is easy to make, and it is also very low cost and cheap. It is suitable for continuous rotation tasks such as driving wheels or conveyors. And the speed also we can control through voltage or pulse width modulation. Hema, just mute your mic. Yeah. Okay. So coming to the applications of DC motors in robotics, basically they are used in robotic wheels or conveyor systems. Coming to the daily life usage, you can see it in your fans and stuff. Now, Hema, like, could you change the slide? Yeah. Coming to the servo motor, a servo motor is a closed loop system comprising of DC motor. Basically, a small DC motor is situated inside the servo motor. A servo motor consists of a DC motor, a gear train, and a potentiometer and a control circuit. So basically, what happens in the servo motor is the motor drives the output shaft through gears, which increases torque. The potentiometer measures the shaft's angular position, providing feedback to the control circuit. So when a signal specifies a desired angle, such if we need a 90 degrees angle or 180, the control circuit compares the actual position through the potentiometer to the target and adjusts the motor's rotation until they match. So when we need a precise angular positioning, we use servo motors in this case. Coming to the key characteristics, as I said, when we need angular control with a defined range, we can use the servo motors, and it has a built-in feedback system for accurate positioning. It is mainly used in controlled motion such as robotic arms or else in RC cars and pan tilt mechanisms. Um, yeah, servo motors are also used in camera gimbals and steering systems. Now coming to the next slide, stepper motor. Basically what happens is in stepper motor there are total 200 steps. That is basically each step contains 1.8 degrees, which is 360 divided by 200, we get with the 1.8. A stepper motor also operates by a series of electromagnetic coils in specific sequence to rotate the rotor in discrete steps. The rotor, typically a permanent magnet or soft iron, it aligns with the magnetic field created by the energy coils. So each electrical pulse moves the rotor by a fixed angle. By controlling the sequence and the frequency of pulses, the motor achieves the precise positioning and the speed without requiring feedback. In servo motors, we have the feedback, but in the stepper motors, we don't have the feedback because we will assume that there is no external load that exceeds its torque capacity. The coils are arranged in phases, as I told, and the driver circuit And coming to the key characteristics of stepper motor, as a servo, it is also used for precise motion fixed increments. It is ideal for exact positioning and no feedback system, as I told. And the thing about this stepper motor is it provides us high torque at low speeds, which is suitable for holding positions. Uh, so it is mainly used in 3D printers. If you are familiar with 3D printers such as made by Ender or something, you have noticed that they have these stepper motors attached in every direction, so it could control the panel base which is there and the height of the nozzle. So yeah, stepper motors are used in 3D printers and CNC machines to control print heads or cutting tools. because they ensure precise movement for accurate designs. And yeah, coming to the next motor, it is BLDC motor, basically brushless DC motor. The thing is, we have some brushes in DC motor which usually wear out after a certain period of time, which causes the wear in the stator, and we cannot use the motor for a long period of time. So the thing is, BLDC actually minimizes this issue, and it acts as an alternate for that problem. Okay. Uh, the working principle of the BLDC motor is, as I told, it is also same as a DC motor, but there will be no brushes. There is also electromagnetic induction that takes place inside the motor. The motor consists of a rotor with a permanent magnet and a stator with multiple coils. An electronic speed controller, basically ESC, is used for these BLDC motors. As in case of DC motors, we can directly attach it to a battery or stuff, but for BLDC motors, we need electronic speed controller to control the speed and the direction of the BLDC motor. Uh, yeah, with this electronic speed controller, it energizes the stator coils in a specific sequence, creating a rotating magnetic field that drives the rotor. The ESC uses sensors like Hall effect sensor or sensorless techniques to detect the rotor's positioning and time the coil activation. So yeah, the ESC ensures the smooth and efficient rotation in case of BLDC motor. This design reduces the friction and wear compared to DC motors. And coming to the key characteristics of BLDC motor, it is highly efficient due to reduced energy losses because there are no brushes present here, and it requires low maintenance. But the thing is, it requires an ESC for operation, and it is used in high performance systems like drones and electronic vehicles, and also remote control vehicles where efficiency and speed are critical. So yeah, that's the part of the motors. Now Hema will continue with the gears.
So when we come to gears, the gear is a, am I audible?
Yeah, you are audible, Hema.
In mechanical gear, in mechanical engineering, a gear is a rotating machine part, typically a wheel that has cut teeth around its circumference. If you see in this image, these hinges part around this wheel, these are called as the teeth of a gear. Actually, a gear is used to transmit rotational motion and, and torque in a system. The applications are to change speed. A gear alters rotational speed with increasing or decreasing torque. As you can see, here is a part. Here is a gear system. To to give a good view about gears and their applications, you can take your bicycle. Take a bicycle. You take. We all have gear cycles, right? These gears will give a shift in the speed in the cycles. They also give torque change and speed changes when come to industrial applications. In the same cycle, between the pedal and in the back wheel, there will be a chain system, as a chain shown here. You can ask, even the chain gives uh, the chain also will change the rotational motion. But the thing is, there are inefficiencies when we use a chain. But a gear is very, very efficient. It's 99% efficient, whereas a chain is only 95% efficient. And there will also be some slipperies in a chain. The next thing is to transmit power. This long shaft has gears on it. So to transmit motion among shafts or track pinion systems, also gears are used. Next is to change the direction. In some cases, there are certain gears where we can change the direction to a perfect of 90 degrees. There are dual gears, many kind of gears. Convert motion. The next application is to convert motion. As I said, rack and pinion setups are used to transfer the motion type. Here's an example of rack and pinion type. As this gear moves, this rotational motion is converted into transverse motions as shown here. This gear rotates as so that this rod will move back and forth. back and forth. These also provide mechanical advantages. They synchronize movement speeds, and there is also much precision when we use gears. And we don't go much with the formulas and nomenclature of gears, but there's just a basic formula. The number of teeth in a gear is inversely proportional to the speed of the gear. This big one, the gear which first forwards the motion is called as the driver gear, and the gear which receives the motion is called as driven gear. So you see the formula, its number of teeth is inversely proportional to the speed of the gears. That's what's shown here. If you want, you can take a screenshot. Z driven is the number of teeth on the driven gear, and Z driver is the number of teeth on the driving gear. Similarly, n is the speed for both of them respectively. When we come to different types of gears, first is the spur gear. This is the very basic, simple model of gears. They have straight teeth, and two parallel shafts can be connected to these both gear systems to transfer the motion. As I said, these are most easiest and cheapest to manufacture, install, and maintain. They will provide a precise, slip-free transfer of motion. The only thing is when operated at high speeds, these gears may cause some noises. That's it. And next gears are helical gears. These are the same to These are very similar to the spur gears, but the thing is, the teeth are cut at an angle. The gear's teeth will be cut at an angle so that it will prevent much prevent friction and ensure smooth rolling across the face. Here also, as it's also same as spur gear. Here also, we will install two parallel shafts. We can receive a smooth operation over here. It can even take upon higher load capacity. The only issue here is the axial thrust generated. To manage this thrust in the helical gears, we will install thrust bearings, and like spur gears, these won't cause much noise during if they run at high speeds because of the smooth rolling across their faces. It's the advantage over spur gears. The next gear system is dual gears. Here, two cone-shaped wheels are sloped perpendicular to their surfaces. Actually, it's uh, designed to transfer power between shafts where a 90-degree inclination is needed. But according to the change in angle, some other angles are also possible. The thing is, the direction change and the speed ratio will be much more well established here. The applications they are found in automotive differentials. For those who don't know what differential is, in four-wheeler types, where two-wheel drives mostly to change the direction of the vehicle, differential will be used. It should be explained to you later in upcoming sessions. The next gears are worm gears. These are also same. They give perpendicular change for the shafts connected here, over here. The upper part of this gear, this structure is called as worm, which almost looks like a screw. And here is a this is the worm wheel. This total structure gives the worm gear. The worm rotates this its thread pushes the worm wheel so that the motion will occur. It will be you can ask what's the difference between bevel gears and worm gears. The thing is, bevel gears, it's a medium gear ratio. Only 10:1 speed transfer may happen. But in warm gears, 100:1 ratio will also happen, and these are somewhat low efficient when compared to bevel gears. It has the self-locking technology, which means that they can't be back driven, but bevel gears can also be back driven. And the axes in a warm gear are non-intersecting, but in bevel gears we will have intersecting axes. That's it. If you come to the project ideas, you can look upon these things. Gearbox comparison rig. Here you can set up 2 to 3 identical motors with different gearboxes and attach loads to them and compare their speed versus rotation. We get a practical view of the gears, and you can use gears to open close the claw using one motor and learn how gear rotation translates into finger motion. Manual or battery powered, you can. It's no need to be battery powered also. You can to just for your practical listening, you can try it by manual. And the application is also a windshield wiper mechanism will also have the same part. Here you can use a crank slider. Okay, for those who don't know what a crank slider is, we'll teach you it in the upcoming sessions. Just Google it. It's a very simple concept. But I don't have the diagram. From now, Ashish will take on.
Yeah. Okay. One second. So yeah, coming to the career prospects. Yeah, manufacturing and automation. Yeah, as we discussed, this is a core industry for mechatronics, focusing on design and optimizing and implementation, automated production lines. Usually smart factories and stuff to enhance efficiency and precision. And another large industry such as automotive. Mechatronics engineers are crucial for these type of industries such as automotive. And as you know, this is the era of rising EVs and autonomous driving systems and other intelligent vehicle features. So yeah, and robotics, the industry directly leverages mechatronics expertise for designing, building, and programming various types of robots, including industrial service and collaborative robots for applications ranging from assembly to healthcare. And yeah, another rising industry for this sector is healthcare and biomedical. Mechatronics plays a vital role in developing advanced medical devices, surgical robots, prosthetics, and automated diagnostic equipment that improve patient care and surgical precision and logistics and supply chain. Automation is transforming warehouses and distribution centers. As we know, even Amazon is trying to implement automated conveyor belts and delivery system to organize their stuff in their warehouses. Mechatronics engineers design and implement automated guided vehicles (AGVs), robotic sorting systems, and intelligent inventory management solutions. So yeah, these are the career prospects as of now. And coming to the next slide, Q&A. And yeah, if you guys have any questions you want to ask us, you are free. Does anybody have any questions or doubts they would like to get clarified? Okay, then if anybody doesn't have any doubts or questions, we'll wrap this session up. And yeah, last slide, last one. Yeah, if you're looking for connecting with the robotics club, these are our Instagram page. These are the links to our social media platforms: Instagram page, LinkedIn page, WhatsApp group, and Tech Affairs Linktree. So yeah, if you guys want to have a chat, or do want to discuss something with us, you can contact us through these platforms using the QRs. And yeah, thank you for attending this session.